Our objectives for this lesson are the following. Define the parts of a parabola and identify the properties of the parabola. So what is parabola? Parabola is the graph of a quadratic function. It is a curve composed of points which are equidistant from a fixed point called the focus and the fixed line called the directrix. So now I'm going to draw a line. This will be the directrix and the point which is the focus. Now I'm going to draw a line from the focus perpendicular to the directrix, and I'm going to get the midpoint. I'll create another point in such a way that the distance from this point perpendicular to the directrix is the same as the distance from this point to the focus. I'll make another point again, which is equidistant from the directrix and to the focus, and I'll add some more points. I'll do the same thing here. I'll create a point equidistant from the directrix and the focus, and some more points. Now, when I connect these points, I'll be having a parabola. Parts of parabola. Aside from the focus and the directrix, there are other parts of the parabola. The turning point is called the vertex. This is where the changes occur. So from going down to going up, this is the vertex. And then, draw a line that passes through the focus and parallel to the directrix. This is called the latus rectum. The distance from the vertex to the directrix is the same as the distance from the vertex to the focus, and denoted by letter P. While the distance from the two ends of the latus rectum is 4p. And a line that passes through the focus and the vertex that is perpendicular to the directrix is called the axis of symmetry. Things that you have to remember about parabola. 1. Parabola is the graph of a quadratic function. Next, the parabola opens upward or downward. 3. The turning point is called the vertex. 4. If the value of a is greater than 0, the parabola opens upward, and it has a minimum point. 5. If the value of a is less than 0, the parabola opens downward, and it has a maximum point. Next, the line that passes through focus and vertex and divides the graph into two parts such that one is a reflection of the other is called axis of symmetry. 7. If the quadratic function is in vertex form, y is equal to a times the quantity x minus h squared plus k, the vertex is the point hk. Next, the equation of the axis of symmetry is x equals h. So whatever is your h here. Next, k is the minimum or maximum value of the function. 10. The domain of a quadratic function is always the set of all real numbers. 11. If the parabola opens upward, the range is y is greater than or equal to k. So here. And 12, if the parabola opens downward, the range is y is less than or equal to k. Here are some application of parabolas in the real world. Now, let us graph a parabola and determine its properties. The first method is through table of values. So let us create table of values. Make sure you have negative x, 0, and positive x values so that your graph is well represented. Let's have an example. Y is equal to x squared minus 2x minus 3. So let us solve the corresponding values of y. Let's have the first one. Let's substitute negative 3 in our x's here. So y is equal to negative 3 squared minus 2 times negative 3 minus 3. Negative 3 squared is 9. Negative 2 times negative 3 is positive 6 minus 3. 9 plus 6 is 15 minus 3. Y is equal to 12. So we write here 12. Continue substituting the x values in the function and complete the table. Once completed, you now plot the points. So let's have the first one. If x is negative 3, your y is 12. X is negative 3, y is 12. Next, if x is negative 2, y is 5. Negative 2, 5. Next, if x is negative 1, 0. If x is 0, negative 3. If x is 1, negative 4. If x is 2, negative 3. If x is 3, 0. If x is 4, you have 5. And if your x is 5, you have 12. You can easily see now the behavior of our parabola. Let us now graph our parabola. It's time to determine the properties. For the vertex, that is the turning point. So here is our vertex. This is actually the lowest y value. So if you take a look at your y values, the lowest value is negative 4. So your vertex is 1, negative 4. So let us place it here. Next, for the opening. Very obvious, the parabola opens upward. And also, take a look at our A here, positive. So indeed, it opens upward. Now, the vertex is at, since the parabola opens upward, then the vertex is at the minimum point. The axis of symmetry passes through the vertex, and it is actually the value of h. So our axis of symmetry, x, is equal to 1. For the domain, since this is a quadratic function, is the set of all real numbers. And last, for the range, since the parabola opens upward, the range is y is greater than or equal to your value of k. So y is greater than or equal to negative 4. Let us solve the same problem, but this time using different approach, using the vertex form. Step 1. Identify where the parabola opens. Positive A opens upward and negative A opens downward. Since our A here is positive, so this parabola opens upward. Step 2. Find H and K. So this will be our vertex. Find time to watch my video on quadratic functions. I discussed there 2 methods in converting general form to vertex form. So now let's identify our A, that is 1, our B, negative 2, and our C, negative 3. Let us have our formulas for H and K. Let's start with H. Let us substitute. So negative of negative 2 divided by 2 times 1. So negative of negative 2 is 2. 2 divided by 2. So our H is equal to 1. Now for our K, let us substitute the values. So 4 times A is 1 times C, which is negative 3, minus our B is negative 2 squared. All over 4 times our A is 1. So 4 times 1 is 4 times negative 3 is negative 12. Negative 2 squared is 4. So negative 12 minus 4 is negative 16. Divided by 4, our K is negative 4. This is now our vertex. So vertex is 1, negative 4. Let us plot it now. 1, negative 4. Our vertex. Step 3. Let us find x and y intercepts. So for x-intercept, all you have to do is to set y equal to 0. So we are going to copy this, but we are going to replace y with 0. So 0 is equal to x squared minus 2x minus 3. This is a trinomial and it is factorable. The factors are x minus 3 and x plus 1. Equate each factor to 0. X minus 3 equals 0, x equals 3. X plus 1 equals 0, x equals negative 1. So for the point, our x is 3 and our y is 0. So we have a point 3, 0. Let's plot that. 3, 0. Next one, our x is negative 1 and our y is 0. So our point is negative 1, 0. So negative 1, 0. Next, for the y-intercept, this time set x equal to 0. Copy this, but replace all the x with 0. So y equals 0 squared minus 2 times 0 minus 3. Cancel, cancel, leaving you with y equals negative 3. So your x is 0, your y is negative 3. So your point is 0, negative 3. So 0, negative 3. So from these 4 points, you can now see the behavior of our parabola. Let us now graph our parabola. Next step, determine the line of symmetry. So the line of symmetry passes through our vertex, and it is actually the value of our h. So line of symmetry is x equals 1. And finally, enumerate the properties. So our vertex, 1, negative 4. The opening, it opens upward. Vertex is at, because it opens upward, the vertex is at the minimum point. The axis of symmetry is here, x equals 1. The domain, since this is a quadratic function, set of all real numbers. And for the range, since it opens upward, y is greater than or equal to the value of k. So y is greater than or equal to negative 4. For now, let us check your understanding. Pause this video if you need more time. Now, for the correct answers, first we determine our ABC. So A is negative 1, B is negative 2, and C is negative 3. Then let us determine our H, negative 1, and our K, negative 2. So our vertex is negative 1, negative 2. For the opening, since this is negative, so it opens downward. Vertex is at, since it opened downwards, then at the maximum point. Axis of symmetry is the value of your h, so x is equal to negative 1. Domain is the set of all real numbers. And for the range, since this is negative, so y is less than or equal to your k. Y is less than or equal to negative 2. Gets?